Geckos. You see them all the time. Climbing up your walls, climbing into your groceries, even climbing into your bed. And yet, how is it that these geckos are able to defy gravity like so? Well, thanks to a special arrangement on their palms of their hands, they're able to stick to things and support their own weight, carrying themselves up a wall. Now, for humans to be able to do this, we would need something very sticky, as we are quite massive. This may be possible thanks to a new invention, well, new breakthroughs, to speak, in the field of nanotechnology, specifically nanoglue. But what exactly is nanotechnology? Well, it's the study of manipulating matter on an atomic and molecular scale. So pretty much really, really small stuff. Generally, nanotechnology deals with developing materials, devices, or other structures possessing at least one dimension sized from 1 to 100 nanometers. To give you some perspective on that, 1 nanometer is 1 billionth of a meter, or 10 to the negative 9th.
Nanoglue is based on self-assembling polymer chains of nanolayers.
The molecules themselves, this part of the molecule likes this place, this part does not like this material. So initially they might lie down like this, but when you put enough of them, they will tend to do this. We used molecules that are known as organosilanes.
Nanolayers consist of a carbon backbone with elements such as carbon, silicon, oxygen, and sulfur attached to the end. Unfortunately, the nanolayers start to crumble at 400 degrees Celsius. Researchers, however, at Rensselaer Polytechnic Institute have discovered that sandwiching a layer of nanoglue between a layer of copper and silica strengthens the bond between the two. Adhesive power actually increases when the nanoglue is exposed to very high temperatures. For example, at 700 degrees Celsius, the bond is 10 times stronger. The molecular composition of the nanolayers can be adapted. Changing the nanolayer composition could allow materials other than copper and silica to be strongly bonded together. This is what Professor Romanoff and his team are trying to figure out. They hope that customizing the chain with different kind of elements will allow the nanoglue to bond to other materials.
And the layer of molecules with the right hooks. So it's like if I put a hook that can keep this side happy, another hook to keep this side happy, and these guys, these guys can be kept apart chemically, but they can be kept together mechanically.
But how is nanoglue made?
So this bottle basically contains, if you want to come look at it, it contains the molecule that forms the nanoglue. And that's the name of the molecule, 3-mercaptopurple trimethoxysilane. And so what we do is we create a very dilute solution of these molecules in a solvent. The solvent we use is toluene, which is not, that's not really important, but basically a very small amount of this in the solution, and then we'll take one of these wafers and just put it in the solution for half an hour, and after half an hour this layer has spontaneously formed on the surface, and then we remove it.
So what is it used for?
Nanoglue is strong enough for a 4x4 millimeter square to hold up a 1,480 gram textbook. Plus, the properties of nanoglue are the same on varying surfaces, such as glass, polymer, and sandpaper. Nanoglue could connect dissimilar materials like insulators, semiconductors, and metals. This lends usefulness for a variety of applications. For example, nanoglue could be used in the low temperatures of space where conventional glues lose grip. It also possesses potential in electrical applications.
Another possibility is using in high temperature paints. Even though these molecules actually become, they pyrolyze or they become unstable, they reform bonds. So they can actually withstand high temperatures. We have shown that they can stay up to 700 degrees centigrade, no problem. Suppose I need to coat a tank. I just need to dip it in another bigger tank which has the molecules. The molecules themselves assemble. And then I put another paint or something on top of that. I heat it up, nothing will happen. And there are several others that you can think about. In fact, there are a lot of doctors who approached me, for using them in for wound healing, using them in dental implants for certain coatings and things like that.
These are possible with Nanoglue, but most are already accomplished with other established methods. Until these methods no longer work, Nanoglue, according to Professor Ramana, will remain a
solution looking for a problem. It's not a quick fix solution. It's not like I go to Walmart and buy Nanoglue and apply and it works. It's a concept.